Hi, and welcome back. So as I mentioned in the lecture and explained, every object in Python has an associated truth value, and we can get the truth value by calling the bool function and passing in that object. And the way it works is that on our custom classes, it's first going to look for the bool method. If it doesn't find it, it's going to then fall back and look for the len method. Now, if the len method exists and returns a number that is non-zero, then the Boolean value will be true, right? Any non-zero number is true, or truthy. And if the len happens to be 0, then it will return false. So that would be consistent with, the truthiness of collection types like lists and tuples and so on. Now, if it doesn't find the len method either, then it just returns true. So by default, instances of our custom classes that don't have bool or len defined are going to be always truthy. Let's take a look at that. So let's create a class. Let's call it person, and I'm going to pass. I'm not going to do anything in that class. I can create an instance of that class, and now I can look at the Boolean truth value of that object, and that is true. So now let's implement the len method. So let's go ahead. Actually, I'll create a new one. Let's say called mylist, and I'll define an init self.length. So I'm going to actually pass in the length of this list. I'm going to store that in a private variable, and then I'm going to create the len method. So def len, and that's basically just going to print out, just so we can see that len was called, and then I'm going to return self._length. Okay, so that's my len method implemented. So now I can create two lists, L1, or two instances of my list, with a length, the first one with a length of 0, and the second one with a length, let's say, of 10. And now I can look at the Boolean truth value of L1, and you'll notice it called the len method. That returned a number 0, which is falsy, so it was evaluated to false. And we can do the same thing with L2, so bool of L2, but that is going to be truthy. Again, the len method was called, but the length here was 10, so that's a true number, and so the result is true. So when we create custom iterables, as long as we have the len method implemented, we can just skip implementing the bool method, because our collection class will now remain consistent with other collection types, right? Empty collections being falsy and otherwise being truthy. But let's just implement the bool method anyways, just to show you that it does call the bool method first, no matter what. So I'm going to implement a bool method, and in addition to the len method. So let's define bool of self, and I'm going to just print out that bool was called, and then I'm going to basically return self._length greater than 0. So I'm just going to keep it consistent with the length, right? But I'm going to do bool, and it's bool, not bol. Okay. So now I can create those two objects again. So let me just copy paste that code, since I'm such a bad typist. So now let's call bool of L1. You'll notice that bool was called, and of course we got a false as expected. And bool of L2, it also called the bool method. Since it found it, that precedes basically preempts the len. Now for classes that do not define the len, therefore, we may want to use the bool method if we want to customize the truthiness for our objects. For example, let's say I've got a 2D point class where I want to consider the origin point, the 0, 0, to be falsy and everything else to be truthy. Well, by default, that's not going to work, because every instance of my point 2D class, if it doesn't have anything that implements the bool method, is just going to be truthy. That's the default, since we don't have a bool or a len method. So let's go ahead and show that. So let's create this point class, and that's going to have an init, and we'll pass in the x and y coordinates, and then we'll just store those in x and y. So self.y equals y, and I'm not going to do anything else. So now I can go ahead and create those 2 points. Let's say 0, 0, and p2 will be 0.1, 1. Now if I look at the Boolean value of 0.1 and the Boolean value of 0.2, you'll see that they're both true, because that's the default behavior. So we need to fix that. So now we're going to implement the bool method. So we'll implement this def bool self, and here the way I'm going to do it is I'm going to return self.x not equal to 0 or self.y not equal to 0. So if the point is 0, 0, what's going to happen is that this is going to be false and this is going to be false. So therefore the OR of that is going to be false. So for the point 0, 0, the return will be a false value. If either of those is non-zero, then this expression would be true and therefore will return true. Okay, so let's test that out and let's see if that works. So P1 equals point 0, 0, and let's say P2 equals point 1, 1, like so. Okay, so now we can look at bool of P1, which is false, and then we can look at bool of P2 now, which is true. Now, note that with associated values, we could technically have tested as well by using this. We could have said bool of P1.x or P1.y, right? We can look at the x and y components, because if x is 0, then this will be falsy, and if y is also 0, this will be falsy, and the whole thing will be falsy. So we could have done it that way as well, right? And then if we do the same thing with P2.x or P2.y, you'll see that we get true, because in both cases, these are both non-zero. And so therefore they're truthy values. So we might want, you might think that we might use this instead of the explicit not equal to 0 comparisons that I had over here, okay? So let's actually try that. Let's go ahead and copy paste this code and take a look at if we could do this. Could we just say return self.x or self.y, right? After all, that's what we were doing here. We can just look at the Boolean value of p1.x or p1.y. So why not just return self.x or self.y? Well, as I mentioned in the lecture, the problem is that the bool method must return a Boolean. Now, we can create an instance of point, let's say point 0, 0, and we can call p1.dunderbool directly. That's fine. That will return 0, right? Because it's returning self.x or self.y. So if we do the Boolean value of this, we get false, okay, as expected. So that works. But if we try and just say bool of p1, it's going to call the dunderbool method, but it's not returning a Boolean, it's returning an integer. Python does not allow that. So it does not implicitly put a bool, convert this to a Boolean value. It wants this to be a Boolean value as a return type of the bool method. So just something to watch out for. So if we wanted to, I guess we could do something like this. We could go ahead and say return bool of that. That would be fine. And now this will work just fine. If I say point 0, 0, then we have bool of p1. That will work just fine. So that's it for Booleans. It's pretty straightforward. So thank you for watching, and I'll see you in the next video.